Hello, greeners. Um, Hopefully the star math thing wasn't too bad. If you haven't done that, make sure to get on that and finish that test. Um, oh, sure. Never stop driving, which is a little misleading because that would be illegal for you guys to do that. So I should probably edit that part out. I'll keep my shirt down here so you can't. I mean, this is bad. Um, so don't do that. Don't drive until you're 16 or you're 15 to get your permit. Actually, it's 14 years old and 10 months. I think you can get your permit. Okay. That being said, let's do math. Today's assignment is 2.1, 2.2. After you've checked your answers for the ACE problems. Remember, contact me if you're not can't figure something out. That's okay. It's normal to not be able to figure out stuff with a really hard class like this. And just so you know, like when we're in person, you would have, or you will be asking a lot of questions. So you can do that virtually as well. So sometimes I can't immediately respond. I maybe talk to somebody else, but I can help you in a lot of different ways. So let me know if something's not making sense to you. Um, some of the stuff is review, as you may have already noticed, like the patterns and all that kind of stuff and basic algebra things. But there's a bunch of new stuff in there too, and it's very much accelerated. So there's a lot happening very quickly. Now I'll get you started on explaining this assignment. So 2.1. Um, yeah, well, I just kind of want to look at it with you. See if the autofocus is still working. I think so. That looks okay. So, mathematical models, like we talked about with your bridge thing, they're not always going to be perfect. So, stuff isn't necessarily going to line up as it's funny when I do this. It's not always going to be lining up perfectly. Okay. Sometimes it's going to be off a little bit, but generally looking for a pattern. Okay. That's why if you look at page 31, this is a linear pattern, believe it or not. Okay, it's not perfectly linear, but it's pretty darn close. So generally, if we were writing an equation for this line, if we were to write an equation that included every single point in this pattern, that would be really, really hard. Okay, like really hard. So why would you do that? That doesn't make any sense. Okay, so what we do instead is we do a best fit line. Okay, a best fit line is a line drawn through the points that minimizes the average distance between the line and the points. Okay, let me repeat. It minimizes the average distance between the line and the points. So it basically makes the errors the smallest possible errors. Or even another way to say it is it basically goes through most of the points, or it gets to as close to the points as it possibly can. So it's kind of like the best fit. Okay. Well, you can look from figure 1 to figure 2. You can obviously tell that one of them fits better than the other one because it's closer to the dots. Okay, there is less residuals, okay, which is the next thing I want to talk about for today's assignment. Residuals. Um, so, okay, residuals are the difference between the actual data and the best fit line. So if we look at like right here, number 2, so for 2 layers, looks like they got, 18. Okay, 2 layers is 18. So these numbers right here correlate with the dots, the actual data that they got when they did their experiment. Predicted by the model would be the dots that you get from the line. So for 2, it's 18 for the actual data, but for the line, it looks like it's probably, I don't know, your guess is as good as mine, 22. So it might be 22. That would be predicted by the model. Okay. The residual is the difference. So in other words, for 2 layers, it's off by about 4 or 3 or 5. It's a matter of your personal opinion, which I fully respect. Not fully, I respect it, mostly, not all the time. Okay, so like for 32, 3 layers is 32. That one looks like that's about perfect. So I would say that the model, the line, is also about 32. And so the residual, the difference between the two, would be 0. So generally the best fit line is going to minimize these residuals. You don't want huge differences between your line and the actual data. You want to keep those as small as possible. Otherwise the model just doesn't work. Okay. Next, so they talk more about predictive models. She gives you an example of an equation, and which one's better, which one's more sophisticated, that kind of stuff. Okay, so I mean, it turns out that the more sophisticated looking one is the one that's less accurate. How ironic. Who would have seen that coming? Yeah, so then they just kind of ask you some questions about that. So that's pretty good. Okay, 2.2. Here you go. These 2 pages, probably the most important 2 pages in the book. That is pages 34 and 35. The infamous pages 34 and 35. Okay. This is review for most all of you. Y equals mx plus b, or linear equations. So that's what they're talking about here. Talking about the y-intercept as being the starting value, or the, how's the camera moving? Oh, weird. Okay. Must be an earthquake or something. The y-intercept, or starting value, or y-intercept, or the b coordinate, it's all the same thing. So it's the starting value. It's like when you're looking at those patterns of like the, how many trusses and rods and things. So it'd be how many rods you started with at 0. Okay. So what is the starting value? In a lot of cases, honestly, the starting value is 0. You start with 0. So like, how much money do I make at my job? Well, if I start at 0 and I make, $10 a day, then it's going to go 0, 10, 20, 30. Okay, so a lot of times they do start at 0. So the y-intercept is often 0, but not always. Okay, and the y-intercept is the one you add at the end. So we'll do more of this. I'm probably going to have to repeat myself many times to do more of this as we go. This is just kind of review, get you started and get you going on. Okay, the second part of the y equals mx plus b equation. So the y is just the y line, that's the up and down. The x is the one going across, the independent and the dependent y and x. The m, so the b is the y-intercept, / many other ways of saying that. M is the slope. Okay, and here is a definition of slope. It is the vertical change divided by the horizontal change. It is also the rise of the over run. It's also the m. It's also how much it goes up or down by each time, et cetera, et cetera, et cetera. I can't even think of all the different ways that slope is set. There are lots of different words and expressions and sayings for slope. Okay, so that is slope. And this stuff, page 2.2, is practice finding slope. So doing the ratio of rise over run. Common question that I get asked is, which 2 points should I use? The answer is, it doesn't matter. You should get the same answer no matter which 2 points you use, but don't use the same point twice, because you'll get a weird answer. So you can't use 1 point to get a slope. There has to be 2 points. There has to be some kind of direction to it. So make sure that you're using 2 different points. Don't care which ones you use. You can probably just use whichever ones seem easiest. Okay. So after you do these practice ones, I also would like for you to do page 10 and 11 out of your folder. Pages 10 and 11. Never start driving. Just kidding. Don't start driving. Yeah. Ooh, I should make another one. Don't start driving. Get some sticky notes or something, put it on there. So the pages 10 and 11 is just practice problems. and hint, hint, nudge, nudge, super secret. The answers are on the next 2 pages. So do one, find the slope or whatever it is, the thing. Do the thing, turn the page, see if you got it right. So those, I just want you to kind of like be able to see the pattern between the problem and then the answer, and just like take some time and really think about how do I get the answer from the problem. Okay. So good job, guys. I'm doing great, and we'll have a quiz here pretty soon. So Monday, I think it is. Yeah, and let me know if you have any questions, and through any means necessary except for ham radio, it's still not working. Okay. Bye, guys.